Good morning. Welcome to our class now. EMT 421 Process Automation 2 Control. So I'm going to share my use step. So where is my use step? Okay, so makita niyo si use step, guys. So naanata diri sa week. Actually, week. Okay, so naanata sa last week, no? Prior to before midterms. Okay, so you may download this PDF file, no? PID control. So PID na ta. Kompleto na ang P and I and D. Okay, so I'll be sharing my slides. Okay. So makita rin ninyo. Okay, so last time we review a video using wheeled robot, no? Line following wheeled robot dayon, particularly using pulolo na sumubot, no? Using PID. Kadumdum pa mga na video, guys. So this time I'll be sharing this self-balancing robot. So dili ni siya upat ka buhok ligid duwara, no? So ako na i-click. Ayun, I'll be posting this one. Post sa share slides. Okay. Ay, pag-share na ko, apel ba ang audio? Audio, share, sound. Okay, so akong i-play. Play. Madunggan nyo, guys. Okay, so nakita niyo yung video, no? Despite na duwa lang kabuk yung liquid, it was able to balance the robot. Okay, so ang sensor na gigamit ato is the kaning accelerometer, no? Or kaning gitawag na inertia sensor. Okay. So, balik to sa tong slides. Okay, so that's it for the self-balancing robot. So, it's using PID, no? PID na control. Kompleto ang P and I and D. So, the sensor is using the inertia sensor or the kinabitang sa phone ninyo, sa inyong accelerometer na sensor sa inyong phone. Similar na siya. And it's using the common na mga parts, no? Okay, so this is our last topic sa kaning PID na different modes. So we're done with on-off control, proportional integral control, as well as the proportional derivative control. So lastly, we are now into the proportional integral derivative or differential control. So what is this? No? It combines all three control modes so that the response anticipates the error, is proportional and immediate, and continues to change until the error is minimum or zero. Okay, so let's review no unsa kining proportional. So proportional means referring to the present error, no? Then the I means the past error. Then the differential or derivative means the future error. So game na silang tulo. The present, the past, and the future. Okay, so for the block diagram, so similar, same naman yapon. No? You have the controller, then the final control element such as the control valve, then you have the process, no? Whatever is the system is referring to process. It may be a dryer system and so on and so forth. Then you have, of course, the sensor, no? Wherein the error is actually ang katong na-sense sa imuhang sensor, which is the process variable, no? Set point minus the process variable. Mana imuhang error. Okay, so just like previous na topic no proportional derivative, so because of the differential na or derivative na controller, it is able to anticipate no the very large error. So manang gamay-gamay na lang yung error, and finally dali na siya mag steady state condition. Okay, so no, the advantage of PID control include immediate reaction to error, a proportional response, and no offset. Okay, so atong tagsa-tagsaon ang ang ganing contribution sa proportional, integral, and derivative respectively. So your PID output, no, at first, no, ang first na gid mo react sa imong output is ang ganing derivative, no, or differential na control, because murag ma-predict niya ang ang future direction sa imong error, no, kung saka ba. So that's why ang first na output is actually derivative output, then followed by the proportional, no, proportional, and in fact it is linear, then followed lastly by integral. Okay, integral to eliminate the or minimize the offset error. So na siya. Okay, so kamo na lang basa sa side notes. Okay, so mga na akong explanation. You just read the side notes if ever na you're going to review the PDF. But if you're going to review the video, no, then much better. Okay, so let's recall the mathematical model of the PID control system. So you have this manipulated variable is actually equal to the proportional controller plus the integral controller plus the differential controller. Okay, so mana P, I, and D respectively. So it is a function of error. Error siya. Where the error is set point minus the process variable or katong output sa imong sensor. Ma-sense niya sa process mismo. Okay, so that's the formula for proportional. For the integral, no, dili kalimtan that the integration is actually the sum of the instantaneous error over time. So mani siya error sa function of time, or simply gives the accumulated offset error. Okay, so kung ma-notice sa drawing, it is the final increase sa imong proportional output. That's why it has a tendency to overshoot. But anyway, then the derivative, no? The derivative. So unsa man derivative? So derivative is the rate of change, no? The rate of change of the error. And it is also interpreted as the slope of the error over time. So slope mo na siya. Okay. Kuan man. Rise over run. Ang run mo is time, respect to time. The rise is the change in error. Okay? Then, of course, it predicts the system's behavior. The derivative is actually the future na it predicts the future of the error. And take note, because derivative has the tendency to spike, create spike output, ganang sudden impulse, particularly if the input is the error is step input, step siya or pulse. So may mo siyang impulse, manatang last na discussion. So there's always additional low pass filter involved. I-add siya para dili mo infinite ang imong output sa imong derivative control or controller. Okay, so we have here a code in Arduino. So mubo ra kani siya na code in Arduino using the self-balancing robot. So atong i-click ang code para makita niyo ang website kung asa na ko gi-refer ni na code. Okay, then allow me to share. Where is now the code? Okay, so mano ang website. So Arduino PID control tutorial. Okay, so mano ito ang block diagram. So dito magsugod sa yung codes. Notice niyo that current time is ginakuha ang current time because the output is always a function of time. The error is as well as a function of time. That's why ginakuha ni mong current time, then ginakuha ni mong elapsed time. So elapsed time, it is actually the current time minus the previous time. So mana ang time it will take for the system to respond. Kung proportional na siya or derivative, so gitawag na time, elapsed time. Then, error. So error is actually set point minus the process variable. But since the process variable is output man sa imong kuan man siya kaning ma-sense sa imong sensor, then actually this is now the input sa imong sensor. So man itong input sa tuwang sensor. Okay? Then, by the way, kaning plus equal is just kuan na siya, isam ni mo ang previous na value para yaning count error. So, mura na siya, accumulative error is equal to accumulative error, previous na accumulative error plus kaning error times elapsed time. So, if you're going to recall integration, it is actually integration of the error itself. The integration of the error of self as a function of time. So mani pasabot. And this is how we're going to formulate or generate the equation in discrete na form. Okay, dili siya continuous na form. So this is a discrete na form. So bali this is sum, summation gini siya. So ginasum nimo ang error function. Then for the derivative, so kung familiar mo sa inyo ang derivative, actually the rate of change, so it's just ano na siya, difference, That's why ang ginagamit nako na term for derivative is most of the time differential. Okay, difference na siya. Just simply take the difference. So error, current error, present error, or the error minus the previous error. Then of course divided by the elapsed time. Then finally, for the PID na output or the mathematical output, kung pa na siya, continuous na form, then this is Kp times error of time, no? Error, function of error plus Ki times integration of error function with respect to time plus Kd times differential or derivative of error sa function of time with respect to time. So since discrete naman natong formula, say discrete, dili siya continuous. So mo na siya. Kp times the error, of course. Error is always a function of time. The present error na siya. No, that is set point minus the process variable nimo. Then the Ki or the proportional gain sa the derived integral gain times the accumulative error, no? So kanin ano siya, i-accumulate niya ang mga previous na mga values ng gisamra niya. So that's why it is the past, no? It will deal the past errors, then kaning it will deal the present error, ang kaning mo ang proportional, whereas the derivative will deal with the future, no? Manang error minus last error. So mo na siya. And that's it, no? Naka-come up na kada yon o PID na output. So inanaon na pag-program. Then of course, ang katong present ni mo na error, may mo na previous na error, last error. Then your current time becomes your previous time. So inana na siya. It's a loop. Okay? So, kung i-apply na nimo, no? So, much better kung double precision na floating point ang gamitan. So, dere, ang proportional gain mo is 2. The integral gain is 5. Then, the derivative gain is 1. So, ano mong mga constants, mga parameters sa proportional, integral, and derivative. Dayon, of course, ikaw na magbuot sa mga set point, no? So, dere, naging mo siya o function, no? Function na compute PID, but actually, maorat atong istoryahan ganiya. No, ganyan siyang hard sa imo PID controller. So, programming the self-balancing robot is not so hard, no? Nanirang iyang pag. Then, if you're going to call the function PID, so ano na? So, yung input na diri is the input, considering na ang kanimong KP, KI, and KD, pwede magyapon ni may butang sa possibility sa imong but it's a global variable man. So, ano dayon? Okay, so ang output na nimo matutun sa base sa imo ang analog na control or pulse width modulation sa imo ang robot, sa imong motor rather. So, magbalance-balance din to siya. Okay? So, na may pangutana when it's come to, pwede po mo magamit sa kaning library niya, no? Para mas gamay rin kayo mo ang output. Okay? So, inana sa kasimple. So, I'm going to share going back or kani. So, na may pangutana guys. So, let's proceed. So, gi-emphasize lang diri that this is actually the discrete formula for the PID, no? Control system.
Sir, question sir.
Yes, sige, may question. Sige,
sir,
pangutana.
Sensor ang gamit sir sa balancing?
Okay, so it's using an inertia sensor or an accelerometer sensor. Okay, so dagan mo siya klase. Nasa katong 3-axis, tapos 6-axis. So depende lang kung sa inyo gamiton. Okay, so ang generic na term is inertia sensor or accelerometer. Present na sa inyong cellphone. No? So depende lang kung sa inyong gamiton. Okay, so it will determine the acceleration, no, the velocity, no, what else? Dili ko siya maka-determine sa kwan. So yung GPS, GPS is a different thing, na global positioning dili siya. Okay? Okay, so napay mga tana. So let's proceed, no? Mga no? So the Kp, the proportional. So of course, you have this formula. Then for the integral, so sa gingon ko pa is just the summation, no, of the errors. So mga tawag na cumulative errors or accumulative error. So kaning plus equal, pareha na siya sa COM error is equal to COM error plus kanina dayon integral, no? The discrete integration. Suma na siya. Dayon lastly for the derivative, so differential, no? Differential ang ginagamit na term. Kung kadumdum pa mo sa inyong limits, no? So the derivative of the function x is actually equal to function of x plus delta x, no? Function of x plus delta x minus function of x divided by delta x, where delta x approaches to 0. So actually it's just giving us the difference, no? Difference. So ang refer na difference kay error man, because the rate of error. So actually, it is the present error minus the previous error. And of course, it's a rate of change man divided by the elapsed time. So present time. Katong current time minus previous time. So a moment, no? Katong pag moment na pag kuhan niya. Dili katong current time lang. Katong yung pila ka seconds, no? How short, no, is the time, no, for the rate of change. Okay? So, namin pangutano before we proceed sa kanya to ang kuhan. Okay, so very good, no? Nanay ng utana in regards to kaning accelerometer. Actually, you can download MATLAB kung dili mo ganahan mag-install. You can download MATLAB sa inyong cellphone. And ang MATLAB, nasa library na ma-access niya accelerometer sa cellphone ninyo. And you can play around with it. Dayon, gusto mo na apoy katong Bluetooth, no? Bluetooth na connection sa inyong cellphone, kaya yung robot, connect ninyo, mo respond ang imuhang robot depending on the acceleration or velocity sa imuhang accelerometer sa imuhang or inertia sensor sa imuhang phone. So pwede na, isa kalit lang mo og forward imuhang phone, mo respond siya ang robot, pwede na. So silang Mac kay gigamit mo to sila phone, no? Bluetooth. Pwede na niya i-add. You try to access the accelerometer or inertia sensor sa inyong phone para additional features sa inyong robot, no? Aside sa katong maggamit lang ka sa inyong remote na up o down, i-try kung nakaya ra ba. Dili ko sure kung naa siya sa features kung ma-access ba nimo siya using ganing MIT App Inventor 2, but i-try lang, marubuto ko na ata. Try ninyo para additional lang siya na parameter sa inyong robot. Okay, so let's proceed now to ingon nila kay discrete man na computation, no? Dili mo siya continuous na computation, so we'll be using Excel, no, to demonstrate how it is being graphed, no, according to the different values of your P, I, and D, no. Then of course there is a gitawag na mathematical na process, no. So this is as a mathematical model of let us say a process, no, a manufacturing process that it has a function of gain, it has a function of time, and it has a function of delay. So mara ginana, no. So nakay output sa imong controller, input nimo sa imong process. So nasi delay gamay before maka-output siya. May some sort. So this is just a mathematical model of a certain natural process. Kaya namin siya exponential, no, sa natural logarithmic na output. Okay, so manotice niyo na ang PID controller was not represented in time domain. Wala lang, no? Pwede mo ni time domain, pwede mo ni frequency domain. But para masabtan ninyo that this time domain PID control, no, is converted to its Laplace transform, no? Or it is transformed into Laplace or S domain or the frequency domain. So yan siya. Instead of C, no, instead of KP, gamit niya C. Then instead of the proportional gain na KP, C ang gamit. Then instead of integral gain na KI, I ang gamit. Then instead of proportional differential gain na KD, D ang gamit. Murag na mali lang siya gamay, there's a typographical error. Dapat kuha na siya I divided by S. Murag na bailo niya. Anyway, okay, so mana iyang Laplace transform. Don't you worry about aning iyang process. It's just kung ano na siya, a representation of a natural na process. No? Sa mathematical lang. Dili ka na siya importante. No? Lagi mo lang siya model to simulate unsa iyang response no, para maka-generate siya process value. Sa to ang atong self-balancing robot, no, mamunto ang robot, so bali ang katong iyang sensor, no, katong output sa iyang sensor na kuan accelerometer, mo to siya, no, mo to ato ang process gid ang kuan self-balancing robot. And iyang output mo itong process variable diri sa sensor mo to input nimo sa imong PID na system. Okay, then of course you can download this Excel or spreadsheet na simulator at the instrumentationtools.com. Pwede na i-download. Ato din kuan. Ako sa nang i-share ang kuan. I-open sa nako ang katong spreadsheet na download naman ako. So where is it? Tara. So akong i-share ko ang spreadsheet. So if you're going to open the spreadsheet, it is password protected, but anyway, pwede read only. Okay? Then there is an instruction and let's proceed to kaning tuning. By the way, sayop na yan, so S na siya, hindi ang I. Okay? Or pwede ipulihan natin value na KP, na yan KI, na yan KD. But anyway, it's the same thing. Okay, so makita mo nyo guys ang spreadsheet ba? So let's go to calculation. So this is the manipulated variable or the output sa imuhang ganing kuan, sa imuhang temperature controller. The PID controller in general. So kanang output MB or the output. But anyway, OP may gigamit sa output. Kaya ito lang gipulig MB. Okay, so diyan sa man pag-compute sa MB. So, kung manotice ninyo, mapadako pa na ako, mapadako. Maura nga po ni guys, no? So, na siya K, so K lang nga po na yung gigamit niya. K times 12, E12. Ano sabi ng E12? Na si E12. E12, it is actually the error, no? Diba? Kung kadamdam mo, proportional constant or P or KP or derivative C times the error as a function of time. Dayon, plus, kanina dayong integral. So, kung manotice niyo, integral lagyan pa ni. Okay? So, nasa 1 by T. No? Nakuha na siya. It's actually the sum lagyan pa na siya. No? Maningiyang ko cumulative error. Dayan 1 by T is the kuan. Okay, so money integral and the differential. So it's actually the difference again na siya sa sabi na E12. What is E12? The present error minus E11. Aming E11. The previous error. Okay, silang dua. Okay? So inana na pagkuha sa imo ang PID. Sa man yung value, so imo ra na nang dapat kabalo mo mag-Excel kay it's very important to perform spreadsheet computation, calculation, especially discrete na computation para masabtan gini niya. So ano yung output. Then of course the set point is set to 1 man dili no 1. Dayon saon man pag-compute sa process variable dili na nato concern no. Kaya naman na siya gitawag na katong mathematical model. So mo na iyang pag-compute sa iyang process variable. Of course, the error, saan ng error? So, the error niya is actually the B18. So, set point minus the process variable. Okay? So, mga ng error. Of course, the cumulative error, mamara na yung previous na summation, no? Summation na sa previous niya na error. Okay? And so on and so forth. So, gigraph din siya, ang ganing output, gigraph din siya, maunanayin niya siya. So, gigraph niya siya, yung output. Okay, so atong padakon gamay. Okay, kanina ay sorry. Okay, so padakon na to. So, we have this now, Juan, kaning PID. Makadumdum pa mo sa inyong PID. Let's say proportional control lang. So, ito 0 ang integral, 0 po ang derivative. So, kung sa'yo manotice niyo ba? So, ang ato ang output, atong set point is mounting 1. No? So, the blue is the process value. So, layo ra kayo sa, ako kaya ang set point error, no? So, let's try to increase the proportional gain. Bata na ito 1. Okay, so, notice niyo na there is oscillation na involved. Dayon, ang iyang steady state na condition, layo gyapon sa iyang 1 na value set point. Okay? So, mao na kung proportional lang na controller. Let us say 1.5. So, baka naman na siya moduol sa sa imong set point na 1, no? Pero, you notice that there is a ubos, it is a function of time. Dugay-dugay siya mag-oscillate siya or gitawag na transient na time or response. Then, steady state na siya, dugay pa. Hanapa siya diri around 140 siguro or 120. Okay? So, as you continually increase 1.9, so, makaduol-duol na siya sa set point but ang iyang steady state na condition is more than 300. If the unit is seconds manata ni, more than 300. So, di na ito na makita na. No? So, therefore, let's apply proportional integral. So, sulayan na ito. Magdugan tag I. Ginabi, 1. What will happen? Okay. Hindi pa mayo. Buta nito 2. Okay. Buta nito 3. Buta nito 4. Buta nito 5. Okay. So, ato pagamihan na ito ang proportional gain. Buta nito 1. Okay. So, actually, na-achieve na niya. The last time, it's around 120 mo siguro. So, karon nakita na nato na nakuha na niya ang wala na siya offset na error, no? Mama na itong process value. Mama na ang output na ito diri sa ang system. No? The output, of course, that is also the feedback sa mga closed loop na system or feedback na control loop na system. Balik siya diri, no? So actually, na-achieve na niya ang steady state na nawala niya ang offset na error. Ano isa sa advantage sa proportional, no? Nawala niya. Like kung ganiya, no? Kung 0 na to ni, muula na to siya, muta na to 1.5. Sorry, 1.5. Naka dol-dol lagi pa niya ang steady state na condition but dako kay ang error, no? O niya to ang set point 1, taas kay ang offset na error. So mo to ang kaning integral, it has the ability to reset, no, or eliminate the offset. So sige itong ibutang niya 5. Dayon kani siya may mong pangabyan lang kay dako ra kayo. Na-eliminate na offset. Okay? So, what if proportional derivative? No? Proportional derivative. So, balik ka sa kwan. So, kung derivative, let's try kung 1 ako ibutang. Okay. So, nawala niyang oscillation, no? Na-notice niya ang oscillation. Kung zero na siya, there is oscillation. So, na-predict niya na mag-oscillate din siya, no? So, iyan ang giputol, no? Giputol niya diretso, gi-anticipate na niya. So, pag-anticipate niya, na murag, di na kayo siya ga-oscillate, no? Well, let's try to increase the value. Okay. So, murag na unstable siya gamay. I-balance na to sa proportional ka. Ay, unstable na. Ito na to, 0.9 ka. 0.9. Kapilapit. Okay. So, more or less, murag na. Padakan na to ang derivative ni. Di pa maayo padakan ang derivative kay kuhaan siya. No, unstable. Diba eh? Mura siya unstable. Diba? Unstable na siya. Okay? So that is for the proportional derivative na may pangutana. So lastly, we're going now to integrate the three, the proportional, integral, and derivative. Paano na siya? Yes, Nay. Murag na nag-chika-chika din. Ano yung nangutana? Guys, na nangutana? Wala. Ako may mute. Mute mo tanan, ha? Okay, so let's continue. Gimute mo na ko tanan. Okay? So, na-appreciate nyo guys ang PID. No? So, ang integral, as learn sa previous natin discussion, ang units niya is in minutes. No? So, that's why in terms of ratio proportion, basta ko ganang integral, 5 siya. Okay? So, na may pangutana? You can download this one, then you can try to simulate. Okay, so then let's proceed sa to ang slides. Okay, so another one is an online simulator, no? PID simulator. So online siya, dili siya Excel. So gi-program siya using online. So i-click na to ni. Tayo, share na ko ng yung so ito na-crack na. Okay, so makita nyo guys, no? So online siya. The set point is blue. So kaning 100, no? So manotice niyo na ang kaning PID na output, magana na siya. Balod-balod. Okay. So what will happen kung i-reset na to, ha? Let's try to reset. So murag enter mo balik. Enter dahil ang kaning KP ay 0 na to ang derivative and 1. So bali, kuhan lang. Ang nilang proportional gain. Napadaka na to proportional gain. Notice yun na mudako po na yung swing siguro. Hindi kayo manotice. Pinakadaka ulit. Okay, so no? So taas yung swing. Ito i-reset be. Set. Then padaka na ito ang proportional gain diretso. So makita niyo na taas kayo siya. Taas kayo. Wala ko na ko ang differential of integral. So it becomes stable. No? This is the proportional. So sige na siya of swing up and down. Okay? For oscillate siya na up and down. Okay? So, ato na po di-reset. What if, kuhan siya, butangan mo o derivative, integral, what is the effect mo? Taas ang giyatag na integral. So, mga mana siya ang effect. Basta sobraan na kataas ang integral mo, yan na kay proportional. So, kuhan siya. But let's try kung ang proportional mo na 1. Agay, nag-overshoot na siya. Inayin na natin. Depende mga na siya sa giset na process, no? And the different processes have different responses. Okay? Okay, and so on and so forth. Ay, dako na kayo derivative na gain. Anyway, so na may pangutana guys. You can play around with this one. with this online simulator if you don't like the Excel version. Okay. So let's continue. So we go back again to our to our temperature controller, the Panasonic Roshinko. So applying PID. So PID can be implemented in both continuous output or discrete voltage output or discrete output. Okay. So, but it is it is better na na piliyon is ang continuous good, continuous na output, such as the 4 to 20 milliamps na output. But then again, pwede ra katong discrete na voltage na output. Bali, mga na siya 0 volts, 12 volts, 0 volts, 12 volts. Mura na siya digital output. No? Kani kay analog output. That's why 4 to 20 milliamps is also referred to as analog. No? Analog output. But if it is 0 and 1 lang or 0 or 12 volts, it is a digital na output. So the PID system could be both implemented using discrete and discrete output or analog or digital na output. Okay, so same is true na gapon din, no? If you're using a final control element such as a pneumatic control valve with smart IP smart positioner or current to peak pressure, manang current mo is 4 to 20 milliamps. Okay, then particularly for the programming or the configuration, the controller, so P, so not a P or the proportional band. Take note, it is proportional band, not proportional gain. So they are inversely proportional. Okay, so familiar to sa term, proportional band. P, no? For the parameter P, and for the parameter I, and for the parameter D. So we go back to the one of the objective why we have to learn PID individually and combinationally, no? Individually and combinational siya because not at all times na pwede siya ma-auto-tune, no? Not at all times na pwede rin siya ma-auto-tune because of the kaning mismatch sa system na sometimes katong gingon lagi na instead of using 1 inch na diameter na final control element na control valve, but since it's not yet available, wala pa niabot, so it's a management decision that to use the existing available na mga 2-inch na bulb. So 2-inch is dako ra kayo para sa 1 inch. So as the control bulb moves up and down or open close proportionally, so there is an erratic na mga changes along the way. No? So that's why you need to understand what is how are you going to adjust manually. It's erratic na yung output, no, particularly the temperature, erratic siya. No? So there is Mano itong gina-discuss. No? How are you going to deal with it? Are you going to increase the proportional band? Are you going to increase the integral time? Are you going to increase or decrease the derivative time? And so on and so forth. So no? So this is the reason why we discuss this. We have a separate discussion for this PID system. Okay, na may pangutana? Okay, so katong wala naka-attendance, no, do not forget to write your last name or first name, last name, completo name, of course, the ID number. Okay, so can you show your camera kay para magkwanta? Random na ganing itawag na attendance o ganing random na picture. Ginawa, pagkita rin mag-screenshot para at least natin documentation. Uy, nabagi apoy miskin dili face-to-face na yung attendance. Okay, so 5, 4, 3, 2, 1. Okay. So katong wala na yung pangutana, no? Pwede na nato i-stop ato ang recording. Okay? Para dili na kayo mataas ng recording. Para may pangutana, kaya ako nang stop. Mana na mag-attendance? Guys? So mag-stop recording na ko. 5, 4, 3, 2, 1. Yes.